And we're back. So the sum, what does sum mean, guys? What's that? Adding. So sum means I'm adding an odd and an even number. And hopefully you know what odd and even are. Every once in a while when I assign the homework at the start of the year and say, do 3 through 13 odds, I have people like have no idea what I'm talking about. So sorry if that's unclear. So odd numbers are the odd numbers, like 1, 3, 5. And then even would be 2, 4, 6. So what conjecture can you make based on adding an odd and an even number together? What would you be able to say about those numbers? Like the sum of them. What's going to happen? Yeah, what do you think? The sum will always be odd. Do you guys agree with her? Michael, do you agree with her? Yeah. So the sum will always be odd. How'd you figure that out? Did you try a few? So hopefully, if you didn't have any idea where to start with it, you just started adding some. If I add 1 and 2, if I add 6 and 5, if I add 4 and 11, trying all these different numbers, I'm going to find out all of the answers are always going to be odd. I can't figure out a way to find one that's not going to be odd. Like I try everything I can possibly do, and it seems like everything's going to be odd. So notice we didn't make a conjecture saying it's going to be a really big number. Like that wouldn't be a good conjecture because obviously 1 plus 2 is 3. That's not a very big number. So it's always going to be odd. So it's coming up with a conclusion based off of what the pattern is. So like, or what you can see. So sometimes you might want to try different numbers and see. Maybe you want to try some really big numbers like 500 and 501. What happens if I add those two together and just check that it does seem to work for all types of numbers? All right, so this next one's kind of a strange one. It's kind of talking about geometry. So they tell us we have points L, M, and N. They tell us LM is 20, MN is 6, and LN is 14, sorry. What can you conclude about these points? Any thoughts on what you think you can conclude about them? What do you think, Lena? They're all even, so those are all even numbers. Or what? Yeah, oh, so that you add 6 and 14 together, it equals 20. Anything else? And those things are true, it looks like. Those are kind of observations. Is there any conclusion you can make about these points? Think about what we know about points. And what are some useful things that we want to know about these points? Yeah?
Point N bisects L and N. L and N.
So you said point N bisects L and M. So you think they're all in the same line?
Yeah.
Okay. So you said N is in the middle of L and M. LM is 20. But then LN would be 14, and then this one would be 6. Does that work? It doesn't bisect it. But what can you say about these 3 points then? What word do we have for that? Do you have a name for that? They're collinear. So you like are just trying to go too far with this. So L, N, and N are collinear. They're all in the same line. Now, so that should be a 6 there. Because this whole thing is 20. If I have 14 and 6, that adds up to 20. You might realize this isn't like a triangle or something, because if this were a triangle, it'd be the most boring triangle ever. It'd be like flat, because 14 and 6 just meet each other to get to 20. So they have to be in the same line. That makes sense that you would add them up. So drawing that out, so Michael's idea kind of got us to the point to realize they are collinear. His initial conjecture maybe did make sense once we kind of dove into it a little bit more. So making some conclusions and maybe drawing a picture or trying some different things and seeing what works. So it's kind of a weird one, but thought I'd mention that type. The last vocab word we're going to talk about is called a counterexample. Gosh. I'm having a wardrobe malfunction here. It's just a second. Okay. So we have an example. Is like a way to show something happened. Like I said, it's nice outside. Mrs. Donahue's going to take us outside because it's nice outside. An example of that was I took you outside today. A counter example is a way to prove that even when it's nice outside, I don't take you outside every single day. You might say, well, we didn't go outside yesterday. You can say, well, there's a test, but that was a day that says I don't take you outside every day. Or it was raining last week. She didn't take us outside. So it's a way to prove a conjecture is false. So it's going to be one example. That proves a statement is false. And I think we tend to do this, like in, again, our everyday lives, that we exaggerate. We say, I always do that. I always do my homework. I always get A's. I always score goals in the game. But someone might be like, you have that friend who's like, oh, I remember that time. Like everyone remembers that one time when that didn't happen. Like, I remember that time you got the B+ on the test, or the game you were shut out. So that one counter example, like I feel like everybody's gonna bring that up every single time. Or, like, I mean, just thinking about that one time that something didn't happen the way you wanted it to. So, for instance, it says if A and B are complementary angles, then they have to share a common side. So we want to draw a picture or show an example of something that would prove this isn't always true. So if A and B are complementary, then they always share a common side. We're trying to show an example of when that doesn't happen. So what does complementary mean again? Go back to our equals 90. So these two together add to 90. Then they automatically have to share a common side. Is there a way to draw two complementary angles that don't share a common side? Yeah, what can I draw? Someone want to come up here and draw it? Who wants to? Give me some angles that are complementary. Give me two angles that are complementary. Just give me the measures. Yeah, go ahead.
60 and 30.
60 and 30. Do they have to share a common side? Nope. So if I draw a 60-degree angle and a 30-degree angle, here's my B, here's my A. Those are examples of complementary angles that don't share a common side. So I don't want to draw an example of this happening. So I'm trying to prove it false. So it's almost like I'm trying to find an error in your reasoning. I'm trying to say, no, that's not right. I mean, my older brother is like this all the time. He's always Googling things and being like, I think you're wrong. And finding that example of where I'm wrong. This is like that older brother that's trying to prove you wrong all the time. So that's what we're trying to do. We're actually trying to prove something false. So this is a false statement. And the reason we can show that is I just showed you an example of where that doesn't have to be the case. The next one says if n is a real number just means basically not imaginary. We haven't talked about imaginary numbers, so you don't really have to worry about them all that much. So if n is just a number, so like any kind of number you want to, basically that's not, again, imaginary, then negative n is going to be a negative. So if I put a negative in front of it, it's always going to be a negative n. Does anyone have an example? Someone give me an n value that makes this not work. Yeah, what do you think?
0.
N is 0. Oh, that's kind of interesting. So yeah, so if n is a real number, so n is 0. Then negative n, it should be a negative, but isn't 0 just 0? Like there's no positive or negative. Does anyone have another one? Yeah.
-1.
Yeah, let's use a negative number to begin with. It's a real number, -1. If I put a negative in to this negative problem, what happens? It becomes a positive. So this is again a false statement, and we gave 2 counterexamples. Now you could keep listing counterexamples for forever, and that would get pretty boring. But that counterexample is just one way to show that doesn't work. Okay. So your homework is listed here for you guys. Again, a lot of these you might have to draw some things out. You might have to explain your work a little bit more. So just make sure you're kind of thorough on your reasoning there. Reminder that missing work, if you guys have missing work, please make sure you guys take care of that and get that back in. Infinite Campus is up to date in my opinion. So if you are disagreeing with that, then you should talk to me about what you think you might have that I don't have. You guys have the rest of the time to get working.